All right, so this one we got to yesterday, and we're still finding the roots of the equation. Now, Nick, you weren't here, so have you done anything like this? Are you up with it, or are you just like, nope? Okay, just for the crowd, he said nope. All right, so what we're going to do is we're going to find alpha and beta. Now, the guys will be able to help you. If you actually have a look just above it, we've actually got general relationship. So the sum of the roots is equal to minus b over a. When we did it yesterday, we found that alpha plus beta equaled minus b, but that was only with monic equations. Does that make sense? So a was 1. So you can see it's minus b over 1 and then c over 1. So all we've done now is this general one is for non-monic. So if we had a 2 or a 3 out the front, we'd be able to do it. So what we're doing in this particular one is we're finding the sum of the two roots, alpha and beta. Then we're going to find the product of the two roots, and then we're going to find the sum of the squares of the roots. So alpha squared plus beta squared. Now I asked the guys to give it a go last night, so we'll go through it for your benefit. Yeah, you cool with that? All right, so we've already got the relationship between them. What colour am I on? I think I'd like blue right now. All right, so alpha plus beta equals minus b over a. Okay, so that's your formula. That's your identity, if you want to call it. So what we're going to write down is, and I'll do the other one while I've still got blue, alpha beta equals c over a. Okay, so I'll do those two and then we'll look at the third one. All right, so write down what you know. So we've written down the formula. Next step, write down what you know. So do we know what alpha is? Well, we're going to work that out. So we've got to write down what what b is. We've got to write down what a is, and we've got to write down what c is. So what's a? 2. What's b? -6. What's c? 1. Awesome. Pretty straightforward. Now you're going to substitute in. So alpha plus beta equals minus 6 over 2, which you should be able to work out is 3. Cool. So that's question A done. Not too difficult. Question B, alpha beta equals c over a. C is 1, a is 2. That's your answer. Cool. Now, a lot of the times, those questions, a lot of the times those questions will not just have nice, simple, straightforward numbers. We're going to have square roots. We're going to have irrational numbers and stuff like that. This example is just based on really nice, straightforward numbers. So just to get you in the habit. But realistically, if you write down the formula, you've got your identities, alpha plus beta, you've got alpha beta, write down what you know. So I've just written it on the side there, and then just substitute in and solve it. Very straightforward. 4 steps. Do it all the time. It works exactly the same. It doesn't matter what the numbers are. Sometimes you'll deal with square roots. It's not a problem. Cool? Excellent. Okay. I'm going to pause now just before we do part C. All right. Part C. Part C actually has alpha squared plus beta squared. Now, I did write up there yesterday, alpha squared plus beta squared does not equal alpha plus beta all squared. Okay, it doesn't. But you can use that as a hint and a way to get around it. Yeah. Oh, that's because it hasn't, I've got to move across. Now it looks like alpha when I scroll across. In the brackets. No, it looks a lot like an A. You know why? I wrote an A. So let's get rid of that. At least I wrote the beta correctly. 1 out of 2 is pretty good for me. All right. So my question to you is what we do. What do we do? Okay, what we've got to do is we know 2 things. We know alpha plus beta. We know alpha beta. Okay, they're the things that we know. And therefore you can do 2 times alpha plus 2 times beta, because that's just 2 times alpha plus beta. In other words, you've just got to try and get this one in a format that you can use. You need it to have just alpha plus betas and alpha betas. Cool? Okay, so I'm saying that these two are not equal. The reason I told you that those two were not equal is because that is where a lot of people go first off. A lot of people go, well, alpha squared plus beta squared is the same as alpha plus beta all squared. Very, very common error. It's not the same. If we have a look at, did it again. It's your fault. Alpha plus beta all squared, that's a perfect square. Square the first, double the product, square the last, yeah? So you end up with alpha squared plus beta squared plus 2, did it again, alpha beta. Okay, that's what you end up with if you take that as a perfect square. Now, does that look like something we can use?
Yes, it does.
We're looking for this, alpha squared plus beta squared. Can you see that if I actually move that over to that side, I will have alpha squared plus beta squared? If I subtract that from both sides, so I end up with alpha plus beta all squared minus 2 alpha beta equals alpha squared plus beta squared. Does that make sense? Now, the good thing is, this is the first time you've seen that sort of process. Now, the brilliant thing about this is that alpha squared plus beta squared is always going to be alpha plus beta all squared minus 2 alpha beta. It's always going to be that. That is a general form. We haven't put numbers in there, so we don't have to worry about it only being correct in this particular case. Does that make sense? So in a way, if you can memorize that particular form, then you never have to revisit it. You don't have to derive it anymore. Okay, it's just there. If you can't remember that, then you just have to remember that we need to get it so that we've got either alpha plus betas or alpha times beta. Okay? You manipulate it until you get it. It's algebra. You can just play with it for a while. Okay? So is that all right with everyone? Looks a bit messy, but is everyone okay with what we've done? All right, so basically what I'm going to do down here in blue, where it's going to be a bit neater, I'm going to go alpha squared plus beta squared equals, and what do I have? Alpha plus beta all squared minus 2 alpha beta. Okay, so I've just rewritten what I had in green, but I've just written it as a bit of an identity, if you will. Is that all right? Looks okay. Okay, now you've got your formula, if you will, down. So now we just substitute in. We've already got the alpha plus beta, it's 3. We've already got the alpha beta, which is a half. So now we're just going to substitute those in. Now, realistically, if you're finding the roots of the equation, it has some weird ass thing that looks a bit like that and it's got extra stuff on top, do these two first, because they're the two you've got. So if you have them and you've already worked them out, you write down A, B, and C, and then you work out alpha plus beta, and then you work out alpha beta. Then you can just plug all these in. So alpha squared plus beta squared equals, well, alpha plus beta is 3, so that's 3 squared minus 2 times a half minus 1 equals 8, and you're done. Is everyone happy with that?